Exactly. You've seen them before, right? This is a complex fraction. That's all it is. Now we're going to do it with variables. You've already done it. That's grade 11 math, right? Anyway, let's do this one first. Okay? All right, a third plus a quarter. So deal with the top, then deal with the bottom. It's like doing proofs. Remember proofs, people? You put the fractions together, you stack them on top of one another, then you flip and you multiply and stuff cancels. Because what about math 12? It's all rigged. And our calculus class, parts of it are rigged. There's a lot of answers of 0, 1, -1, stuff like that, right? Then there's answers like e to the power of 4.3, but that's down the road. All right, 1/3 plus a quarter. How do you add fractions? Common denominator. What's the denominator? So we go 3, 3. You don't even have to show all this. I'm just showing it because it's fun. So I get 4/12 plus 3/12. What's the common denominator for the denominator part of this fraction? So times 4. Once you have a common denominator, how do you add the fractions? You just add the numerators. I love that you said numerators too, instead of just tops. So now you have single fractions. What do you do when you're dividing fractions? Keep, switch, split. Flip and multiply. Does anybody know why you flip fractions and multiply when you're dividing? Or do you just do it because you were told in grade 3, or I don't even know when you learned that? Does anybody actually know why? Yeah, but why? You said exactly what I said. You just said it in a much more elegant way. But why do you flip? No, but why does it doesn't do the? It's the why. Okay, Abigail, and then you. You're on the path. Yeah, that's more for algebra though. You're not wrong. The reason is nobody likes stacked fractions, right? Because they look kind of gross. I don't know what to do with those. So what they do is they want to eliminate the denominator, like this whole thing. How do you eliminate a fraction? How do you make it equal 1? Times it by its reciprocal. So if you multiply the bottom by its reciprocal, that becomes 1, right? Because everything cancels. But what you do to the bottom, you must do to the top. Hence, keep, switch, multiply. That's why you do it. All right? Nobody ever tells you that. Every year I teach calculus, I tell people that, and nobody's ever told them that before. It's just you do, like in grade 4, I don't know when you learn to do this. You just do what you're told, right? So now we're going to multiply. So there's 2 ways to do this. One, you can just multiply the tops. You're going to get big numbers. Or you can simplify first. I prefer to simplify because I don't like dealing with big numbers. All right? So the one way that I would do it is I'm going to go, I can't divide 8/5, I can't divide. 7/12, I can't divide. But 8 and 12, do they have a common denominator? Or a common factor, I guess? 4, right? 8 can be divided by 4, which is 2. 12 can be divided by 4, which is 3. So now it's 7 over 3 times 2 over 5. What's 7 times 2? What's 3 times 5? And then you have the reduced form. Or, if you don't like that, you can just go 7 times 8. What's 7 times 8? What's 12 times 5? Get that and then reduce it. But if the first step, you're dealing with smaller numbers, and you'll get to the reduced form faster. I mean, it doesn't matter. You get there in the same spot. One way it's like direct, one way it's a little. Maybe you want to go the country road and get there. Doesn't matter. You'll get there. All right. We okay with that? Does Helena speak for everybody? All right, here we go. So now we're done with numbers. One over A minus 1 over B over 3 over AB. What do we do? Which is AB. So the technical way is you go, I multiply this by B, or sorry, by A. A, and B, right? What's the fast, quick, and dirty method that you would do? What's the fast way to do it? What? Just do it? Slam these together. That goes there, that goes there. That's the fast way to do it. So you go B minus A over AB. Does everybody understand that? Because that'll be faster, right? It's important that you understand how you get a common denominator, but the quick is, or the fast way to do it, is you're just going to put the denominators together, and that's going to multiply up, and that's going to multiply up. So now you have stacked fractions, which we like. Then what do? Keep, switch, flip, or whatever. The ABs will cancel. What are you left with? B minus A over 3. Are we good? Three. All right, this is math. This will bring back fond memories of your Math 11 class. All right. Do we have to make common denominators or anything? No, because they're just stacked fractions. There's no addition or subtraction. So we do the flip and multiply. All right. Are we done? Why? Yes. If you have a quadratic, what do you do? Factor. Okay. What's x squared minus 25? Factored. Yep. Difference of squares, so it's x plus 5, x minus 5. Go away. Why? What's 4x squared minus 1? Yeah, it's a difference of squares. So it's 2x plus 1, 2x minus 1. Okay, before we cancel anything, what do you have to remember when you have variables in denominators? You have domain restrictions. What is x not allowed to be? Good question. So if you look here, plus or minus 5. What about here? Plus or minus 1/2, right? Because that would make the denominator 0. Is there anything else that we have to account for? Are we good? Okay, we are, but just be careful. If you look at the original, this one here, you would go, okay, there's x can't be 5. There's the x can't be plus or minus 5, right? But remember, when you're dividing fractions, this bit, you're flipping it, and it becomes the denominator. So you have to be careful of that. Sometimes stuff pops up, all right? And you can miss what am I trying to say? A restriction, all right? So now we can just simplify and cancel. What cancels? If you cancel everything up top, what are you left with? Perfect. That's it. Only got 2 more examples left. What's the common denominator of the top? Yeah, put them together. Remember the fast way? And then you can just cross those up. I mean, what you're actually doing is you're multiplying this one by x minus 1, like that, right? So the fast way is just put them together and cross them up. So you're going to get 3. 3 times x plus 2 plus 4 times x minus 1 over x minus 1, x plus 2, all over. Do the same for the denominator. Is that right? Or do people agree, I guess? Do we have a consensus? Okay. Last one. Oh, restrictions? Oh, okay. What are the restrictions? What is x not allowed to be? Hmm? right? If you put 17 over 2 into here, it's going to blow up too, right, at the end. Okay. Now, just because I didn't want you to forget your math 10 or math 12. I'll let you wrestle with that one on your own. You don't have to do restrictions. Or should we do restrictions? We do restrictions, then it ties. Oh, we should do restrictions. Let's do restrictions. Simplify it first. We'll do the restrictions together. Okay? All right. So the top. Let's talk about the top. We need a common denominator. What is it? Cos times sine, right? So essentially, that's going there. That's going there. You know that you're actually. Thank you. So you're crossing them up essentially. So you get sine times sine, which is sine squared theta, cos times cos, which is cos squared theta, over cos theta sine theta. Yes? Why does that make you happy? Yeah. Sine squared plus cos squared is the Pythagorean identity, and it equals 1. So we'll deal with that in a sec. The bottom, you have to change everything to sine and cosine. Tangent is sine theta over cos theta. Secant is 1 over cos theta. So really you got a lot of stuff going on here. You got 3 fractions stacked on top of one another. Okay? Let's deal with the top. And by the top, I mean this thing. All right. Sine squared plus cos squared is 1. So that just simplifies to 1 over cos theta sine theta. Over. What do you do when you're dividing fractions? Flip and multiply, right? Yes? Okay, what cancels? Boom. Cosines are gone. So now you're left with 1 over cos theta sine theta over sine theta. You could write the sine theta over 1 if that makes you feel better. Now what do you do with fractions? Flip and multiply. What's sine times sine? So now you've got 1 over cos sine squared. Okay, you could leave it there, or what could you write? Oh, I didn't even. Okay. Does that clean up nicely, or does that get ugly? Is it gets ugly? Okay, we'll do that in a sec. What I did is I went like this. What's 1 over cos? What's 1 over sine squared? What's 1 over sine? Cosecant. What's 1 over sine squared? I did that. Now, this isn't a proof, so it's like, where do you stop, right? what other people, I guess, did, you subbed out the sine squared. Is that what, that's what you did, Kirsten? Oh, you could sub out the sine squared as 1 minus cos squared. That's, I don't think that works out well. You're gonna get cos minus cos cubed. Nah, I don't want to deal with that. The point is, look, if you got to this point, that's really all that matters. Okay, so just know how to simplify. The trig stuff doesn't play a big role in this course, but it does pop up occasionally, and with limit, like it's sprinkled throughout. So being able to manipulate a function by getting a common denominator, knowing a few identities is important for this course. Okay, but it's not everything for the course. Your algebra is like very, very important. Okay. All right, I'm going to give you a worksheet that has some complex fractions on it. Stop.